Heading: Synchronous motor. First point. A synchronous motor is an AC motor that runs at constant speed called synchronous speed. Second point. The rotor rotates exactly at the same speed as the rotating magnetic field. Third point. It works on the principle of magnetic locking between stator and rotor fields. Heading: Principle of synchronous motor. First point. When three-phase AC supply is given to the stator, it produces a rotating magnetic field. Second point. The rotor is excited by DC supply to produce a constant magnetic field. Third point. The rotor locks with the rotating magnetic field and rotates at synchronous speed. Heading: Effect of varying excitation of synchronous motor. Side heading: Underexcitation. First point. When excitation is low, the motor draws lagging current. Second point. The motor behaves like an inductive load. Third point. Power factor becomes lagging. Side heading: Normal excitation. First point. The motor operates at unity power factor. Second point. It draws minimum current for given load. Third point. Efficiency is high. Side heading: Overexcitation. First point. When excitation is high, the motor draws leading current. Second point. The motor behaves like a capacitor. Third point. It improves power factor of the system. Heading: Applications of synchronous motor. First point. Used in power factor correction. Second point. Used in constant speed industrial drives. Third point. Used in compressors and pumps. Fourth point. Used in steel mills and rolling mills. Fifth point. Used in timing devices and synchronous clocks. Heading: Choice of AC motor. First point. Induction motors are chosen for general purpose and low-cost applications. Second point. Synchronous motors are chosen where constant speed and power factor correction are required. Third point. Single-phase motors are used for domestic low-power applications. Fourth point. Slip-ring motors are used where high starting torque is required. Heading: Advantages of synchronous motor. First point. Runs at constant speed irrespective of load. Second point. Can operate at leading, lagging, or unity power factor. Third point. High efficiency. Fourth point. Suitable for power factor correction. Heading: Disadvantages of synchronous motor. First point. Not self-starting. Second point. Requires DC excitation. Third point. High cost and complex construction. Fourth point. Requires skilled maintenance.